we don't see anything going on in the room, but this is kind of what you'll see in the video, what's happening here. And if I use like a pointer like this, if I point somewhere in the screen, you'll see the pointing up here. If I write stuff on it, you'll see it afterwards. So it's pretty useful to see this. Anyway, so we're going to talk about today specifically the types of drafting that we're going to look at. And there are going to be two types we're looking at here, isometric and orthographic. So let's take a look at this next slide to start with. Everybody has it now at this point?
Yeah.
Okay, cool. All right, so isometric. First look at an angle. Again, eraser, but not turn like this, turned at an angle. So we can see the three-dimensional perspective of it. So that's the first. You don't have this, Jim? Look at. The second one is called orthographic. And orthographic, again, is what's called a projection. A projection. So in geometry, if you had a shape that looked like, let's see. Oh, here's a good one. You know those sugar cookies during Christmas time? They come in like it looks like a log almost, and you just slice it, and you slice the cookies. I make my own cookies, but personally, if you buy cookies that are in log form ahead of time, you slice it, right? You slice a bunch of cookies, or like, you ever get bologna, or salami, or pepperoni?
Yeah.
Okay, so you slice a pepperoni stick like that? So if you're going to slice a pepperoni stick, or the cookie one, whatever, what shapes do you get when you slice? What shapes? Yeah, circles, right? A bunch of circles. And then they have some thickness to them. They look like coasters almost. That's kind of like what we're doing here. It's like taking a slice of what you're looking at. Now here's the thing. If I were to take a slice of this piece right here, I would only get this little front piece. I wouldn't get what's in the back. If I were to take a slice back here, it would be different because I would get part of the back, not the front. So what we're really doing here is this. We're just visualizing and looking from this angle. So if I were to look at this object from this angle, from the right side, from the side plane here, I would see this rectangle right there, which is that. I would see this rectangle here, which is that. And I would see this rectangle right here, which is this. So again, what's happening here is that we're looking at an image, or we're looking at an object from the side, which makes it look like a simple two-dimensional image. So to reiterate, I'm going to use colors so you guys can see this a bit better. So I'm a teacher, right? But I still like to learn. And this is something that I learned from a student last semester. Because somebody was like, oh, Mr. Howell, why don't we just color code it? And I was like, oh, that's a great idea. So instead, what we did was this. We said, you know what? We'll color this region right here blue. We'll color that blue. And we'll color that blue. And what parts of that? That's this part right here. That's what we're physically seeing. We're seeing these three faces. Then we'll use another color for the other side to see it better. So I'll use red now. For the red one, I'm doing this right here. And this part right here. And that's what we're seeing on the front plane. And then last but not least, I'll use green. For green, I'm looking at this L up top. And then the rest of this object part right here where it says the word object. And that is everything we're seeing up here. Okay? So this is physically what we're doing. It's easier to see it, I think, by using these colors. So when you're doing it, it may be worthwhile for you when you're doing drafting practice to start to color code different parts as you draw them. So part of what you're going to do is learn how to take what we have as a solid here and draw the three different orthographic views. And then the harder part, so this is like the easier part, drawing these three. The harder part is like, what if I gave you the three orthographic views? Can you recreate the solid? So imagine you didn't have this in the middle, but you only had these three views. You'd have to figure out, okay, what does this mean? Does this show depth? And it gets a little bit tricky, but we'll go through that process together to show you how to do it. Okay, but these are the orthographic views. All right, let's go on. So when we relate the two, like we saw in the last one, another example is all this is. We've got, again, a front view, we've got a side view, and we've got a top view. And try on your own, spend about, a minute or two, and do the same color coding yourself. Okay, and I want to come by and look and see how you've done. So figure out what spots here correspond to what shapes over here. And take a look at the views that you have. I'm looking at the side. I see this. This is looking at the top. This is above. This kind of wouldn't correspond to that one. Yes, so just this part right here to start, right? And then keep thinking that you're looking from that angle to look at. can obviously work with the person next to you and check with the person next to you also. It's a nice method to use. Jimmy's using a couple different colors for each view, actually, instead of using the same color, so you can designate which is which. That works too. Nice. Very good. I like it. I see you did the color code on the side. That works. Nice. So this should be your blue, right? This should be your side view. See your blue here. The color doesn't matter, okay, but for what you did, I'm saying. So, because you call it side.
That was side.
It doesn't, honestly, the names don't matter as much.
I thought, it's my fault.
So I would change that to blue and that one because it red there. By the way, side view, front view, top view, those are phrases that I'm going to use, but based on different websites you might look at or different texts, they might call the side view here the front view and might call the front view the side view. It's really no difference. It's about corresponding to your figure. That's all that matters. Top view, though, is really the same every time. It's from above, right? Top view, what's another phrase for that? What do you call that if you say top view?
Aerial.
Aerial or?
Bird's eye.
Or bird's eye. Aerial or bird's eye. Aerial meaning from above, from the air. Bird's eye, from the eye of a bird. Okay, so from above, from the top. So most of you got this right away. Let me just take a look again, make sure everything's good. Is that right also? Yeah. Okay, good. So, all right. Good. Okay. So again, really easy to get the orthographic views from the isometric and match them up. But again, if I gave you only orthographic, which we're going to do in a little bit, then drawing isometric could be a little tougher. So we're trying to go slowly into this. Next slide. So here's what we're talking about now. So we have a front and a side view. Just a front and a side view. No top view is given in this case. And the dimensions are given. So we're given dimensions of D, W, and H. So when drawing an isometric perspective, what we're going to use in this course is called a isometric grid. Actually, let me share that with you real quick. I'm going to put it on, I'll put it on documents and handouts. So go back to documents and handouts real quick, and I'm going to load a file there that says, it's going to be called isometric grid. God bless you. And give it a second to load. What do you want to do the files? God bless you. Once that loads, guys, okay? It's going to be isometric grid at the very bottom. So what I'd like you to do with this once it loads is click on it on your iPad, okay? And then save it, please, to your camera roll. Because there's going to come a couple times where you're going to want to use an isometric grid. So by saving one on there, you'll be able to use it in the future. So as soon as it loads as a JPEG, click on it. It's probably going to open in a new tab. Save it to your photo reel, camera roll, whatever it's called nowadays. And then what you could actually do is we can load it onto this screen to overlap or overlay on top of the image. Come on. I'll show you what it's going to look like so you guys can see. This is what it'll look like. Okay? And why do you think it looks like this? Take a look at it. So what does it show? What is it showing you by looking? It's not a normal XY axis, right? Or what that's called a Cartesian, the normal one? What does it show you?
It shows depth.
Depth. It shows depth. And the reason it shows depth, think about an object going straight back along these lines, right? That would show the depth that we're looking at. So we're going to be using these grid lines to draw our shapes and objects. Is it up there yet? Man. All right, note to self. I got to make sure these are ready. Well, now they are, but taking forever. Okay, I'm going to go back to the other slide so you guys can see it. But when it's ready, just go ahead and click on that. So notice we're seeing depth here, right? We see the depth going back. So I'm just going to step you through this process. You're not going to be drawing this one. So let's just warm. So that's step 1. And step 2, what we do is we see, okay, the front view has a distance d across. That's this distance right here, because this is the front view. The side view has a height of h. That's this height right here, looking in from the side, seeing this rectangle right here. And what do you think this is going to be labeled as right here? What do you think this dimension will be labeled as in a moment from here to here? Yeah, that's going to be w. And try to make sense of it, right? Take this, that's the w right there. This height right here is this height right there. This d value is this value of d, the depth. Okay, so this is slowly building. Oh, it actually loaded as an image. If you click on it, what happens?
You have to do save image.
Can you do that? Hold it, save image? That's really weird. I've never seen that.
Oh,
I have an idea what I'll do. I'll load it as a file afterward. Let's see. Yeah, file resource. Let's do that too. I might, yeah, it'll be there for a little bit, but you guys can hold on it
If you
and then
double
save
tap
it.
it, you get a page of it.
Yeah, there's.
Oh, it brings up a whole page. Nice, yeah. So, but you want to keep that in your camera roll somewhere so that when you need it later on, it'll be there. Yeah, but definitely save it in camera roll because I'm going to send you other files in Notability, and you might want to access them and put that little grid on there at some point. But yeah, Notability is a good idea too. All right, the next page, see this? So the next slide, we're seeing that we have the final step or the final object. And this is just simply a brick, right? A rectangular solid is all it is. So to start you off with a very, very simple example of isometric views, again, of a brick. Let's take a look at the next one here. So isometric view of front steps. Front steps. What are you thinking about right now? Staircase, right? Front steps. So the front steps of like someone's house. So look at the side and the front view. And on your own, ask yourself, what does this look like? Like physically, what does it look like? And try to sketch what you think it'll look like over here. Don't go to the next slide. Obviously, you can go to the next slide and see the answers. But try to do it on your own the first time through. Look at what we've got here and try to think about how you would maybe add in lines to make it look like this from the front, right? This is front over here. And make it look like this from the side. How would those line up accordingly? God bless you. And once you've drawn it, and you've got an idea or sketched it or tried it, then go to the next slide and see what it actually does look like. Okay, go to the next slide and take a look and get an idea if your sketch was accurate or not. So this is what the author's starting point was, starting with like what looks like a brick. And then it looks like they're going to start shaving away the parts that shouldn't be there. So it's happening. So if you go to step 2 or 3, if you're having trouble, step 3 shows that they have first this brick-looking shape, and then they start to overlay what the front looks like. Right? This right here is this right here. So since the front, we don't see anything right here. Take a look, right? That's empty space where I'm pointing. So since that's empty space, there's probably going to be one right here, a channel grooved out, right? Like a channel that's been milled or removed from the part. This is how things were made a long time ago, by the way. They would have a solid, and then they would use what's called a CNC mill and remove parts of the solid to create the piece. Now, because 3D printing is so prevalent, you print from nothing and you build instead. So I was in I'll give you an example. When I was in engineering school, for freshman year, we got these wax blocks, like a block of wax, like hard wax. And we had to program on the computer coding to get this little spinning, what's called a driver, to move around and cut out parts of the wax. So one of our first ones was like make a chess piece. So you had to get the thing to move around. You had the circular curvature to like either the castle or the pawn or whatever shape you were looking at. And it would simply just shave it away and remove parts. And that's kind of the way it's building here. So that's the one. Then if you look at the next part, we'll see, now we're kind of like removing this part. And this is the channel we're talking about that's going to be grooved out. So the final 5 or the final shape it's going to look like looks like this. And if you look at it, it makes sense, right? Because now the front view here lines up with the front view here. And then the side view, I see two rectangles, which are really this rectangle here and this one right here. So be careful. We're not looking at the top view right now. We haven't gotten to any shapes that are too complex that we even need a top view. So it's possible to draw your isometric drawing without the top, front, and side if it's a simple enough shape. Okay, a simple enough shape. Let's look at the third here. So here we have three views. So this is one of the times that it's probably worthwhile for you to take a look slowly, one step at a time, and try to visualize what it is. So since this is the front view, take a look here, right, the front view, you might want to think about like just drawing in all the shapes you see here on the front view. And then from the side, drawing in all the shapes that we're seeing on the side. And then we can slowly erase stuff and move back to the third dimension. If you want to, you can overlay that orthographic or that isometric grid line, that image right on top of here if it helps, so that you can move along the grid lines. But I'm giving you these three lines as starting points here. Okay, when you actually practice it though, you're going to do it right on the actual grid lines so that your lines are nice and straight. By the way, on the iPad, it's really useful that you can do straight lines. Do you know how to do that? Does everybody know how to do straight lines in Notability? You drag and then you hold at the end, okay? And then you can move that straight line and you can change its pitch or its angle. So that would become really useful. And it's also going to be useful when I give you guys the isometric and you draw these guys on grids, because it'll lock to the grid lines actually. It'll lock nicely on those like sticky notes, those grid sticky notes, whatever they're called. So if I'm thinking about this, hold on one sec. So step two, the author thinks, or let's start with this brick. Let's start with this solid, get an idea of what it is, right? And then I said to you guys, hey, take these shapes you're seeing and try to overlay them on each of them. So what does this author do to start then? What shape did they already take into account, or what view? The top, the side, the front? The top for sure. Because look at the top view. Already, take a look. All of this is removed, right? Everybody see that from a bird's eye view? So that's this channel right here. This missing piece that's not there. That's what's been physically removed. Again, this is our solid right here. This is what we're looking at. And what have we done? We've drawn a line with a marker, pretty much here, like that. This is the part of the top view that does exist. This is the part that does not exist. So if you were to literally destroy, or if you're like Cyclops, anybody X-Men fan or not? Nobody for X-Men, really? Not even one person likes X-Men?
I watched it.
You watched it? Okay. Thanks, Jim. I appreciate that. Now, Cyclops has like a laser thing. He shoots out of his eyes, and whatever it hits, it literally just destroys, like erases it from existence. So that's the same concept here. So this just completely removes this chunk through. And that's what the first step is showing. Second step, notice, from the front, we can remove this part, right? So this is my top view right there. Okay, then I look at the front view, and I should be removing this part right there. So now take that and channel that out. So now we're here. So if I channel this whole thing out, it means that I'm removing this piece that goes throughout the entire thing. So I'm really just removing this cube right there. And that has to do with the top view also. If you look at the top view. Right, there's that part right there for the top view. Okay, so we channel out this word. The word is bore. We bore out this channel right here and completely remove that entire piece, that section of it. Which we see on the next slide, right? So now we're missing those parts. Does the side view line up properly? Let's take a look. So we've got, again, front view, right? Here's our front view, and I'm missing this line right here. There's my front view. We've got our top view, and then our side view needs to line up. So if I was looking at it like this, right, and I would turn it from the top, this line should continue straight down. This line represents the cube that's kind of removed from the corner over here. And then that's it from the side view, right? Here's my side view. We've got these three rectangles, 1, 2, 3. So really we're removing this entire chunk, this whole channel across, and that's actually all we have to remove to get to the side. Okay, so these pieces are removed, but I want you guys, when you're doing it, to be thinking about the 3 different views as you're going through. This one is a little bit easier, I think. So you're only given a side and a top view. You're not given a front view. You're not given a front view. So if you start with this shape that's here, work on asking yourself, what lines belong where? Right? What lines belong where? And if I look at this shape right now, I can see that on the top view, I've got 2 lines there. Right? I've got a line here and a line here. So start by putting a line right here and right here. Make sure to get those 2 lines in to start. Then the side view takes a look. What shape is this? Who knows their shapes well enough by now? Trapezoid. So the front view, or the side view rather, shows a trapezoid here, but we can see that this is pitched, right? It's at an angle, and this gap is D. So maybe you label this right here, right there. Label that as D, label that as D, and we need to see those angled lines on the trapezoid from the front. So let's take a look at what that looks like. We're going to see the first part, right? The side view has been taken into account with this line right here. And this distance D is the same as this distance right here, D from the top. Then we're going to take a look and replicate it on the other side, which is like a mirror image, right? A mirror image, reflections. We're going to talk a lot about reflections, rotations, and translations. All things that you're going to cover you've covered in algebra class, you're going to be talking about in geometry course. In algebra 2, you're going to study this stuff. So reflections, rotations, and translations are really important. And the concept of mirroring something is going to come into play a role. Take a look at the next final here, and we can see there's our shape. Okay, so all we have to remove were pretty much these triangular channels, right? This triangle right here and this triangle right here were simply removed into the page, which is showing why these parts are no longer here. They are now missing. Okay. So this last one here, we start with a simpler first step here. So the first step is taking into account which? Top, front, or side view? Which has the first step already taken into account? The top, the front, or the side view? The front. Okay, so all we removed was this channel or this area right here, which is coming from right here in the front that's not there. Okay, so the first step takes into account the front view. Now try on your own to take into account the other parts. Think about putting a line across here and cutting this part away. Think about the top view. From the top, we have a missing piece right here, right? So let's put that missing piece down here somewhere. Looks like it should start here and go to there, which is going across to here. Let's take the second step then. So the second step, what do they take into account? The front, top, or side? The side. Very good, Ben. The side. It's this piece right here that's missing, right? From the side, that's this piece right here that's about to be removed. Then we take into account the top view. The top is missing this piece right over here in the corner, and that's shown right here. This piece is starting to miss in the corner. And the final product looks like it seems here. We've got the top taken into account. By the way, the top is a little bit tricky.
Yeah.
I'm going to pause on this, I know, but because this looks like a rectangle, right? And yet this is slanted, but if you looked at this from above, it would be a rectangle. This shape right here is a rectangle, and that's this right here. So on Friday, when you come on in, you grab a laptop, have your headphones with you. If you don't have a flash drive for Friday, it's not the end of the world, but definitely have it for next week going forward. And please sign and submit the syllabus for the class. Okay? Guys, have a good day. Good job with this today.
Thank you.
Jimmy, any word back from Max?